Headline: From a frozen desert to a lush paradise. Witness the multi-generational transformation of the red planet. Description: in this installment of Astral Adventure, we explore the breathtaking concept of terraforming Mars. Through cinematic visuals, we follow the milestones of planetary evolution, from the initial melting of the polar ice caps to the introduction of advanced bioengineered species that create the first Martian forests. Key phases featured: atmospheric thickening, releasing greenhouse gases to trap heat; liquid water stability, the first rains on the Tharsis plains; the seeding stage, introducing mosses and genetically modified plants; the blue horizon, a breathable atmosphere and permanent human settlements. Mars, the red planet, is a dry, rocky, and bitter cold world. It is about half the size of Earth, yet has the same amount of dry land. Sending humans there is the current next frontier for space agencies, with the moon serving as a critical training ground. NASA, Gov, the red planet, environment and facts. Atmosphere, mostly carbon dioxide, 95% and very thin, less than 1% of Earth's. Gravity, approximately 38% of Earth's. You would feel much lighter and could lift heavier objects easily. Day length, a Martian day, called a sol, is 24 hours and 39 minutes, very similar to Earth. Moons, it has two small asteroid-like moons named Phobos and Deimos. NASA.gov, human missions, timelines and plans. Humanity is currently using robotic pathfinders like the Perseverance rover to scout for resources and landing sites. NASA.gov, NASA targets the late 2030s to early 2040s for the first human landing. NASA's Artemis program is the stepping stone, testing long-term life support on the moon before the 6 to 7 month journey to Mars. SpaceX, Elon Musk recently shifted focus, shelving the 2026 uncrewed Mars target to prioritize lunar missions first. He now estimates uncrewed Starship flights to Mars may happen in 5 to 7 years, around 2031 and 2033. China has proposed missions as early as 2033, focusing on a credible track record of robotic lunar and Martian success. The weak critical challenges: for astronauts, sending humans alive and keeping them healthy is much harder than sending a rover. Astronomy magazine radiation. Deep space is filled with cosmic rays and solar particles. Without Earth's magnetic field, astronauts risk severe DNA damage and cancer. Landing heavy payloads. Mars' atmosphere is too thin for large parachutes to be effective, but too thick to ignore. Landing a 5,100-ton crew vehicle safely is a technology that does not yet exist. Physical health. Months in microgravity lead to bone and muscle loss. On the surface, the weak 38% gravity may never fully allow a body to recover to Earth normal strength. Resource needs. To stay long-term, humans must learn to pull oxygen from the atmosphere using tools like Moxie and find subsurface ice for water and fuel. Mars is a dynamic, rocky world that is both remarkably similar to and dangerously different from Earth. While it is a cold desert today, evidence shows it once had a warm, watery past. Key physical characteristics: size and gravity. Mars is about half the size of Earth. Its lower density results in only 38% of Earth's gravity. If you weigh 100 pounds on Earth, you would weigh just 38 pounds there. A rusty surface. The planet's signature red color comes from iron oxide, rust in its soil and rocks. Extreme weather. It has massive dust storms that can last for months and occasionally cover the entire planet. NASA.gov. Geography and atmosphere. Thin air. The atmosphere is 95-96% carbon dioxide and is less than 1% as thick as Earth's, providing almost no protection from space radiation. Extreme temperatures. Average temperatures are around 85 degrees, 65 degrees, though they can swing from 70 degrees, 20 degrees at the equator during midday to 225 degrees, 153 degrees C at the poles. Record-breaking landmarks. Olympus Mons, the largest volcano in the solar system, standing 3 times higher than Mount Everest. Valles Marineris, a canyon system so long it would stretch from New York to California. NASA.gov, the mystery of water. Scientists have confirmed that while liquid water cannot exist for long on the surface due to low pressure, it is present in other forms. Polar ice caps, large deposits of water ice and frozen carbon dioxide. dry ice at both poles. Deep reservoirs. Recent seismic data from NASA's InSight lander suggests vast reservoirs of liquid water may be trapped 6 to 12 miles deep in the Martian crust. Ancient history. Billions of years ago, Mars likely had rivers, lakes, and a northern ocean. Exploration status, 2026. Active missions. Mars is currently explored by a fleet of robots, including NASA's Perseverance and Curiosity rovers. Human timeline. NASA aims to send astronauts as early as the 2030s, using the Artemis moon missions to test deep space survival technologies. Mars is often called Earth's cousin because they share similar day lengths and axial tilts, but the physical differences are stark. Key facts at a glance feature: Earth-Mars, diameter 7,926 miles, 12,756 km, 4,220 miles, 6,791 kilometers, surface gravity 1g, 100%, 0.38 g, 30%, average temperature 57 degree, 14 degree, 81 degree, 63 degrees, atmospheric pressure 1030.25 mu, 100%, 6.1 modesty mu, 0.6% of Earth, length of day, Sol, 23 degrees, 56.24, 37 millimeter length of year, 365.25 days, 687 days, atmosphere composition, nitrogen 78%, oxygen 21%, carbon dioxide 95%, nitrogen 2.7%. The Artemis Base Camp, humanity's lunar foothold. As we prepare for the Red Planet, NASA is developing the Artemis Base Camp at the lunar South Pole. This site serves as a vital testbed for the technologies needed to survive on Mars. Foundation surface habitat, a permanent home for 4 astronauts to stay for up to 2 months at a time. Lunar Terrain Vehicle, LTV, an unpressurized rover that allows astronauts to explore the surface in their spacesuits. Pressurized rover, a mobile home that allows crews to travel hundreds of miles from the base camp for weeks without needing to wear a suit inside. Target site. The South Pole is prioritized because its shadowed craters contain water ice, which can be turned into oxygen and rocket fuel, a process humans must master before heading to Mars. As of April 2026, humanity is actively testing the technologies required to survive on Mars through the Artemis II mission and robotic explorations on the Red Planet. Life support technology, the Moon as a test bed. The Artemis Base Camp near the lunar South Pole is the primary site for testing the closed-loop systems needed for the 3-year journey to Mars. Regenerative ECLSS, the Environmental Control and Life Support System, ECLSS, on the current Artemis II mission is a regenerative breakthrough. It is designed to scrub carbon dioxide and regulate temperature without relying on immediate resupply from Earth. ISRU, in situ resource utilization. Scientists are deploying instruments like the Lunar Dielectric Analyzer and heat-sensing cameras to locate water ice in shadowed craters. This ice will eventually be processed into drinking water, breathable oxygen, and liquid hydrogen rocket fuel. Advanced spacesuits. Newer Axiom-designed suits are being tested for better mobility and radiation protection, essential for the rugged Martian terrain. Perseverance rover, current path in Mars GPS. Perseverance continues to explore Jezero Crater, currently navigating the crater's rim after traveling over 41 kilometers, 25.8 miles, since its 2021 landing. New Mars GPS. In February 2026, NASA upgraded the rover with a global localization system. This allows it to use its own cameras to pinpoint its location within 25 centimeters by matching landscapes to orbital maps, rather than waiting for humans to tell it where it is. MOXIE results. The MOXIE instrument on the rover successfully proved it can extract breathable oxygen from the 95% carbon dioxide Martian atmosphere. AI navigation. The rover now uses generative AI to plan drive routes autonomously, allowing it to travel twice as far each day while searching for biosignatures in ancient lakebed rocks. The Perseverance sample collection. The Mars sample return cache. The Perseverance rover has currently collected 24 unique samples and counting from the Jezero crater. These are sealed in titanium tubes, waiting for a future mission to bring them to Earth. Key samples collected: igneous rocks, the foundation. The first samples, like Montagnier and Montagnac, were volcanic rocks from the crater floor, helping scientists date the age of the crater. Sedimentary delta rocks, samples like Wildcat Ridge and Skinner Ridge, were taken from an ancient river delta. They are rich in mudstone and siltstone, the best places to look for fossilized microbial life. Carbonate-rich samples like Lotus Peak, contain minerals that formed in water, which could have preserved signs of Mars' ancient